Okay, let's take a look at some of the mechanics and the physiology behind breathing. So it's all based on the ideal gas law, PV equals nRT. So pressure times volume is equal to some sort of constant. So that means that pressure and volume are inversely proportional to each other. So that means that if volume goes up, then the pressure must drop. Or if the volume drops, then the pressure must go up. Okay, so what does that mean? Well, let's take a look at it. On the left-hand side here, we've got inspiration, or taking a breath in, and on the right-hand side, we've got expiration, or breathing out, exhaling. So in order to get air in, we have to lower the pressure inside the chest, such that the pressure is lower in the thoracic cavity than out here in the atmospheric atmosphere, like the room, okay? And if the pressure is high out here and low here, air will flow in. Same thing with expiration. If the pressure is high in the chest and low out here, we will then exhale passively. All right, so how do we drop the pressure inside the chest? Well, if we want the pressure to drop, we've got to increase the volume. In order to increase the volume, normally, when you breathe normally, your diaphragm is a dome-shaped muscle that separates the thoracic cavity from the abdominal cavity. Well, when it contracts, it actually flattens out. And when it flattens out, it decreases the pressure in the thoracic cavity because it increases the volume. Look at compared to this guy here. The volume is small. Here the volume is large. In addition, we've got external intercostal muscles. So these muscles here, like when you buy ribs, when you order ribs from a restaurant or make your own ribs, those muscles, when they contract, they pull the chest cavity, the thoracic cage, up and out, also increasing the volume. So both the diaphragm contracting and the external intercostal muscles contracting, both of those increase the volume, thereby dropping the pressure. And when the pressure's low in here and high out here, you take a breath in. Expiration is the opposite. When the diaphragm relaxes and when the external intercostal muscles relax, the volume of the thoracic cavity drops, and when the volume drops, the pressure increases. So now we have high pressure here, low pressure out here, air will flow out, and the patient exhales. So, what are some things that affect breathing? Well, first of all, breathing is controlled by the brain stem. So this portion of the brain here, the lower center portion of the brain, and the parts that control breathing are the medulla and the pons. And we have chemoreceptors throughout the body that sense carbon dioxide concentration, oxygen concentration, and hydrogen ion concentration. The brackets mean concentration, okay? Hydrogen ion concentration, they're also called protons. So they're used interchangeably because a hydrogen ion is simply a hydrogen atom that has had an electron removed from it. And a hydrogen atom, to begin with, only has a proton and an electron. There are no neutrons in a hydrogen atom. So therefore, if you have a hydrogen atom that you take an electron away, by definition, that now turns it into an ion, specifically a cation, because it has a positive charge. So that's measuring pH. Okay, so if we increase the amount of carbon dioxide in the bloodstream, we call that hypercarbia or hypercapnia. You'll see they're interchangeable. They both mean the same thing. If we have a low amount of carbon dioxide in the bloodstream, we call that hypocarbia or hypocapnia. If we have a low concentration of oxygen in the bloodstream, we call that hypoxia. And as a reminder, if your pH drops, that's because of an increased concentration of hydrogen ions, and we call that acidosis. If your pH increases, that's because we don't have a lot of hydrogen ions in the bloodstream. We call that alkalosis. Okay? And those factors affect respiratory rate and respiratory depth. And again, that's controlled here by the brain stem. And the way we normally breathe is your diaphragm and your external intercostal muscles normally contract and relax to increase and decrease the volume in the thoracic cavity. But if we need to get, because if our CO2, our O2 or pH are off, we might need a little bit of help. In that case, we have accessory muscles, and those accessory respiratory muscles include the internal intercostal muscles, which normally are in a relaxed state. These contract, and there are a couple other muscles like the scalenes that are in the neck. If you ever see somebody having a really tough time breathing, you'll see neck muscles, they will contract and relax and contract and relax. Those are what we call accessory muscles, respiratory muscles. And if they are in use, that means the patient's work of breathing is increased, which means the person is having a tough time breathing or is having respiratory distress. The technical term we use for that is dyspnea, D-Y-S-P-N-E-A. P-N-E-A means air or to breathe. Dys means dysfunction. Okay. And lastly, we need to mention partial pressures. So think of it as a pizza pie. Over here we've got oxygen. This is half of a plain pizza. Over here we've got nitrogen, half of a pepperoni pizza, but together they form a whole pizza. So basically what a partial pressure is the force exerted by a certain gas on a mixture. So the pressure of oxygen on a mixture plus the pressure of nitrogen on a mixture, we add those together, and that's the pressure of the entire mixture. And that is signified by P sub X. So it would be like, for example, PaO2 or PaCO2. That means partial pressure.